Today, have I shared my screen?
Yes. Sure.
Today we will do one vital thing that is
Okay.
called Cartesian product.
Okay. Cartesian product.
Okay. Now, what Cartesian product is? Before going deep into Cartesian product, I would like to tell you that whatever we did so far was
Hmm.
basically on a single table. Means
Yes.
just we are opening the schema, this company schema. We are working on this company schema. Okay.
Yes.
So whatever we did so far is something like that, finding the names of employees from different cities, mm, some employees name who earn more than or less than some salary. Okay. Some
Yes.
project
Select
name,
command. Yes.
some
Select
project name.
command.
Yeah, select command,
Completely
obviously.
we worked it. We worked it
Whatever we
completely on.
did, it
Hmm.
worked on a single table, either on this table or on
Yes.
this table or on this table. Okay. But in
Hmm.
real life, the queries are not
Hmm.
so simple.
Simple. Yes.
It may be combined. Okay.
Hmm.
How? It's something like that.
From
Suppose,
different
yeah,
tables, the data could be taken.
say suppose, let me copy it. Uh, no, just let it be there. Suppose, see, if I ask you to,
Hmm.
have I discussed it, this Cartesian product?
No, select command only.
Only
Cartesian
select.
product
Cartesian product
only
we did.
select.
Okay.
We did. But one or two things we have seen that joining table also, like taking the result from query from two table also. We have done it like department whose salary could be only so much, something like that.
Okay. Cartesian product we did not completed, na?
No,
You
mention. No,
remember?
no, no. We did.
Cartesian. Okay.
Yes,
Okay.
we did not.
So Cartesian product.
When when we were doing multiple means select a command, we have some few queries we have seen selecting from two table. That's it.
Okay, that's it. Okay.
Mm.
Cartesian product is basically something like that. Suppose there is a table and
Mm.
you have some records, okay,
Mm.
and there are some other table. It also have some records, okay. So what Cartesian product is means if you perform Cartesian product between these two, okay. So it will, if you remember the Cartesian product from mathematics, okay,
Yes,
MFCA. So it is the combination of
row and
every
column. Row
no every row of table 1 to every row of table 2.
table two.
That is Cartesian product. Okay.
Mm.
Suppose this is T1 table.
Mm.
These are the sets. You remember from MFCA.
Ma-
These are
yes,
the two sets. Okay. Yeah, and in database, often these tables are referred as set. It is a
set.
very deep relation with set theory in mathematics. Okay.
Mm.
Because indeed this is a set, na set of all
Set
records.
of all records.
This column is even a set. This is a set of all data in a
Mm.
column. This is even a set. This is a set of all columns. We called it as a tuple. Anyway, so Cartesian product is basically the combination of every record with
Hmm.
every record
Of
of
table
the
two.
table 2. Okay. So where we need actually this thing. Suppose, look at this table. If I ask you to find the name of certain employees, then you can
Hmm.
easily find the name looking at this table. Na?
Yes.
But suppose if I tell you, tell me the name of the employee who lives in Delhi. So what you will say? This person lives in Delhi. This person lives in Delhi. Right. So you name these two persons,
Yes.
Virat Kohli and Yuvraj. Okay. If I ask you, tell me the name of the, uh, tell me the ID, SSN of the
Or
employee
the employee.
who works in department number 10. Then
Okay.
what you will do? You will
So
look into this department column.
their
Assistant,
I and SSN
his
should.
ID is
Mm.
1003. You will
Mm.
reply me.
Yes.
Now tell me, if I ask you, find the name of the employee who works in
Mm.
department 10, that is easily gettable from this table.
Yes.
Okay. But
JMP table. Mm.
if I ask you, find the name of the employee who works in
Different
production
project.
department. If I
Then
ask
I
you,
should look into two different tables.
then you have to look into two different tables. First of all, you have to go to this table,
Mm.
JDEPT, where
Mm.
you have to find the
Production
production column, means
column
department with related
and
to the name is production. There, from there, if you want to do the task manually, from there you have to get the department number of the production department, right?
yes.
After that, you have to come into this table.
Mm.
Here in this column, you have to find where which
That
rows are
as
associated
well
with the
as
4.
four.
Okay. So
Yes.
with those 4 columns, means this is associated with 4, this is also associated with 4, this is also, these are all
Mm.
associated with 4.
Give it the four.
So these names you will fetch from
Yes.
this table. So manually you can do this task. Okay.
Okay.
But how can you do this using a query, SQL query? Okay.
Okay.
So you must know that SQL query,
Mm.
we have different kinds of language, na? DDL, DML, everything.
Yes. DCL. Mm.
But the only command in
Mm.
SQL that can
Mm.
fetch the data out of a table, that is select.
Mm.
You know that. And
Yes.
you also, now I'm telling you that select
Mm.
can operate on only one table.
Okay.
Select can operate
Put it on one table.
only on one table. But here we cannot put all the data in a single table because that will be a mess. Okay,
Yes.
that will
I
that
cannot
is not a,
organize.
yeah, exactly, that will not be an organized structure of database. Okay,
Yes.
so to get a more efficient organization of data, we
Mm.
must divide the records into
Mm.
different tables, different
Yes.
separate tables into. Okay,
Mm.
so now when we want to fetch a record or information like that, what we have
Mm.
just said, okay, what you have
Mm.
to do, you have to collect all those data into a single table,
Mm.
and that table will be created in runtime, temporary table.
Yes.
Okay, so on that temporary table, what you have to do, you have to run the SQL query. Now
Okay.
see here. So these are the two different tables. Okay,
Mm.
so we know that we cannot run a single query on two different tables. So
Yes.
for that purpose, what we did, we
We
make a
create
Cartesian product.
con Cartesian product.
Cartesian product of these two tables,
JEMP table and J department table.
say T1 and T2. Okay.
Mm.
And when you do Cartesian product, you all know that here it has 3 records, here it has 2 records. So in this column, you will have 3 multiplied
In
by 2
by two,
records.
6 records.
And here you have 3 columns, and here you have 3 columns. So you will have 6 columns here.
Six
Now
columns here. Yes.
1, 2, 3, 4, 5, and 6 columns. Okay. So
Mm.
now see, all the records come into this table now. Okay.
Mm.
Is it okay up to this?
Yes.
Now you apply your SQL, write a suitable SQL for this table
Mm.
and get the result. This is the technique. That's why we need the Cartesian product. We need the Cartesian product because SQL cannot run on multiple tables. Okay.
Mm-hmm.
So to make a temporary table where all the data can be put together. Okay, we do
mm,
Cartesian product. Cartesian product will bring all the data as a
mm,
combination in a single table,
mm,
and on that
mm.
single table we will run that particular SQL query, a suitable SQL query, so that we can get our desired result.
Okay.
Is it okay?
Okay.
Okay, fine. Now you remember that when you put a SQL query, I just said
Mm,
you write a suitable SQL query. No?
mm,
That suitable SQL query must come with a condition, no?
mm.
Because otherwise suitable SQL query means what? SQL query is
SQL.
SQL query without any where clause is nothing, just a select the data
S-
from the table. No?
mm.
So to make a suitable SQL query, you need a specific condition. You have to apply a
Yes.
condition
Some
here.
criteria we have to give.
Yeah, you have to write the condition, suitable condition. Okay,
Mm,
okay. Now see, we have two things. As I told you,
mm.
I will go parallelly with relational algebra and the SQL. Okay,
Okay.
so first let me introduce you how in relational algebra we can do this. Okay, just take an
Mm,
example. Say your T1 and T2 are the two. Say T1 cross T2
okay.
will be your
Relational algebra.
Cartesian product. T1 and T2. This is the syntax. How you have to
Okay.
perform the Cartesian product in relational algebra notation.
Mm.
RA means relational algebra. Okay.
Yes.
In SQL or in RDBMS, wherever I write RA, you will
It is
understand that this is a
relational.
relational algebra. Okay.
Mm,
So now see, this table becomes R. This
mm,
table becomes R. Okay.
mm.
So R is your T1 cross T2 means
Cross T2.
now in
Cartesian product of both the
Cartesian product
tables.
has already been performed and that
Mm.
all the combinations are stored in R.
R.
Okay. So better I name it as R1. It is R1.
Okay.
Now this table, this is the temporary table. This table
Yes.
contains all combination.
All
Okay. But
combination.
what we want? We want our specific result. Huh?
Specific result.
So
Mm.
to get the specific result means our result, what we will do? We will
Condition we have to
put a select query
cover.
on R1. On R1 table, we will put a select query and give our specific condition here.
Hmm.
You remember the syntax of
Yes.
select
Yes.
I discussed in last class?
Yes. In relational algebra
Yeah,
notation.
condition. Okay.
Hmm.
So this is our specific condition. On the basis of this condition, this is our
Hmm.
specific condition. Okay.
Condition.
Depending on this specific condition, we will get our final result, and this will be our final result. So two operations are involved in relational algebra
Relational algebra.
in order to get the queries from multiple tables. One is
Yes.
your Cartesian product, and after that,
That
you have to
specific
perform
condition.
the select operation.
Select
Okay.
operation.
If you want to get a few columns, not all the columns, then you obviously can use the pi, the projection
Hmm.
over
Projection.
the
Hmm.
select operation. So that is a
Yes.
different thing. Okay, but
Hmm.
basically these two operations are needed to get the final result in relational algebra for Cartesian product. Okay.
Yes.
Okay. Now in SQL, what you have to do? You have to write something like that. In SQL, so this is SQL. Select, say maybe star. Star means every combination,
All records.
all columns. Select
Columns.
star
Hmm.
from T1 comma T2
Hmm.
where the specific condition. That's all.
Hmm.
Simple.
Yes.
So what is this? This is
Yes.
basically the Cartesian product. It is performing. If you write this thing, if you write this line, So it will perform the Cartesian product
Cartesian product
of
and
between
makes
T1 and T2.
and give
Okay.
us R
And temporarily it will produce this table, and on this table this condition will be
where
applied.
condition will be applied.
Depending on this condition, the result will be shown here.
Hmm.
बोलिए है ना simple. So
Yes,
these are two same things.
different. Ah,
Same things.
but
It is in
notation
relational
is
algebra.
different.
This is
It is an
relational
SQ.
algebra. You cannot run
Yes,
this thing. Okay.
yes.
This is algorithm basically. And this
Hmm.
is SQL. You can run it. Okay.
Yes,
So Cartesian product is clear. So we will
yes,
go with
clear.
the example now.
Okay.
Real example.
So whenever we do the any query with multiple tables, this is what is going to be happen. It will create a temporary table with the
If
Cartesian
you
product,
perform
and then
Cartesian
the
product,
circle will.
no, if you perform Cartesian product, if you write like this, so it will perform Cartesian product behind the scene. Okay.
Mm-hmm. My question was like, if we are sometimes whenever in Access also we do with multiple table, there also this same thing at the back end is going to be happened.
I'm not getting you then.
Say for example in MS Access,
Mm-hmm.
we create multiple table,
Mm-hmm.
and there also we write a query for
Mm-hmm.
selecting a data from multiple table.
Mm-hmm.
So at
Yeah.
the back end, it is going to happen like this only. So wherever, whenever we
Mm.
write, is it going to happen in the same way? And my question was that,
Yeah,
like it
yeah.
will create the Cartesian product table, temporary
Mm.
table, and
Mm.
from there it will run a condition on that.
Mm.
Okay.
Basically, see, in MS Access you can do two things basically.
Uh,
Okay, one you can
we
do
just
with the
drag the
SQL
table.
query,
Hmm.
and the other thing you can do by using the GUI. Okay,
Hmm.
you drag the table and you do all those sorts of things. Okay,
Yes.
so that thing is also
Hmm.
same like this. Okay,
Mm-hmm.
so whenever you do that kind of thing, behind the scene it is performing operations like
Same
that.
thing. Mm-hmm.
Okay, but one thing I must tell you here, that in MS Access, those all dragging and uh, those all dragging options in GUI,
Mm.
there is a separate language that is
Oh,
called
oh.
query by example. Okay, that can
Mm-hmm.
also be performed in MS Access. QBE, query by
Mm.
example. Okay, and that is basically the graphical user using the graphical user interface. Okay, but what I am telling you here about Cartesian product, that is true for what you are mentioned, what you have mentioned here. When you drag the two tables, okay,
Mm.
and you get the data out of that tables,
Mm.
okay. So behind the scene, there must be a way to make the Cartesian product and run the query. Okay,
Okay.
so that is Cartesian product too. Okay,
Okay.
here I mentioned this because that is the thing you also know, that in MS Access there is something called query by example. Okay, that is a
Okay.
that is completely different from relational algebra and SQL. Although the result and outcome will be same. Okay,
Okay.
so we forget this thing for the time being. We do not need this
Okay.
thing. Okay, that is not a very easiest thing of doing. Means that will not be required for our application development
Mm-hmm.
and for our university purpose. Okay.
Okay.
Okay. Let's move to here. Okay. So what was our query? Our query was,
Selecting.
let me write the query first.
Mm.
Select the employee names who work in which department?
Purchase department 4.
Production department.
Oh,
Right.
sorry, production department 4.
Production department. So this is our query. We have to
Mm.
perform this. So let me write the query
Mm.
in SQL first. Then we will do
Mm.
it in. Acha. We have those tables here now. Say, how can we check?
Yes, that application
Select
builder
star from
star from
JEMP. select star from JDPT,
JDPT.
right?
Mm. We can select it from here also, no? That application builder,
Yeah, we
that
can go,
table.
but
Last time
always,
we did
always try to
do with
write
commands.
query. Okay,
Okay.
see these are the data,
Mm.
and for DPT, we will also have the data for. Okay,
Mm.
so now just step by step, I am showing you. First,
Mm.
do the Cartesian product. Means we are combining the two records. Okay.
Yes.
Now see, how can we do that? Select star, because we have to learn how to see here. I mentioned already, everything is depend on this condition. Now.
Yes.
Everything is depend on this
Depending on the
condition.
specific condition.
So you have to know how, what will be the best condition so that we can get our result. And not only the best condition, here also that time complexity and the
Yes.
efficiency will come into play, because you have to put a condition in such a way that the data has been fetched
Hmm.
in the, I mean the minimum amount of time, in minimum amount of time. Okay,
Okay.
the fastest way to fetch the data.
Yeah.
Acha.
Okay.
Select star from, what you have to do, JEMP,
JEMP.
comma JDPT.
JDPT.
Now run it. See,
Hmm. Okay.
just I am increasing the number of rows here so that we can get the full listing. See here,
Listing.
see here. How many rows
Hmm.
are there?
48 rows are there.
48 rows. How many rows were there in JEMP? See, there are 12
There are
rows.
12 rows.
And how many rows are there in JDPT? 4. So
4.
4 into 12
12 fours
means
are
48.
48
So you have total 48 number of rows here.
rows.
Just take a snap of this thing. Let me take a snap. Side paint. I have to take. See here. That is enough. I think. See, this is a part of the table, part of the row
Hmm.
I took. Na?
Hmm.
From this picture, you can understand that there are many more rows, 48, total 48 rows are there.
48 rows are there.
Now look here. See, this is the record of Sachin. Na? This is the
Yes.
record of Sachin Tendulkar, Mumbai, DNO.
Did 4.
He works in Department 4,
Hmm.
and this is the record of Department 4. And Department 4 is production department. Okay.
Production.
Acha. Next, look at this record. Okay, just a minute. I'm using this green. Sachin Tendulkar, Mumbai. So he works in Department 4, and this is the record of Department 4 too. So this is the record of Department 4. You identify that this part of this combination is coming from DEPT, right? And this part is coming from
From
this. This is
JEP. J,
JDEPT. This is your
JEMP.
JEMP.
JEP.
This part, okay? You can
Hmm.
clearly visible. So
Yes.
this is the section, right?
Yes.
Okay. Now look at the next record. Rahul Dabir, Bengaluru. He works in Department 5, but with him the combination is of Department 4. So
Okay.
can't I say that this is the wrong combination?
Yes.
And that is same for this is, right?
Yes.
So this is a wrong combination. What is this?
It is 4 same. It is correct.
It is correct combination. This is correct combination. This is correct combination. This is correct combination.
Again wrong.
Again, this is wrong. This is
Next
also
one is
wrong.
wrong.
This is correct.
Correct.
This is also
Remaining are
wrong.
wrong. All are
Remaining
wrong
are
also.
wrong. Okay. Now, among these few records, what you have seen that most of the records, most of the combinations are wrong. Na?
Yes.
These combinations, these wrong tuples
Mm.
records have a good name that is
Oh,
called spurious tuple.
okay, okay.
Spurious means what? What you say? Spurious. Spurious means the extra erroneous
Okay,
tuples. Okay,
okay,
that is
okay.
you can say it's a byproduct. Okay,
Byproduct. Okay.
so spurious tuples means erroneous information related tuples. Okay, so by
Mm-hmm.
Cartesian product, there is every chance, not every chance, obviously, there will be lots of spurious tuples.
Mm.
Okay, so it will be very much more number than the actual
Mm-hmm.
true tuples, true combinations.
Okay.
Okay, is it clear?
Yes.
Now, among these all tuples, among these all records, you have to identify which one is your right combination. Because see, since we identify that this combination is our right combination,
Mm.
and this combination is our right combination, and this combination is our right combination, look into this record. Sachin Tendulkar, if you want to find the name of the department where Sachin Tendulkar is actually working, you will
Mm.
get from this combination, this record.
Yes. Mm.
If you want to find the name of the employee where name of the employee mm, who is working, one of the employee who is working under production department, you can get it from
Virat
these
Kohli.
records. Virat
Mm.
Kohli, Sachin Tendulkar, Rohit Sharma.
Rohit Sharma.
Okay, so these are the records we need to distinguish. But how? How can we
Specific completion.
distinguish among all other rules? We have to relate these fields. See, these are
Mm.
the common fields of the two tables. Now,
Mm.
these are the common fields of the two tables. So you have to match up these columns, these values.
Mm.
See here, for the means the for the true records, true combinations, mean the actually
Mm.
valid
Mm.
combinations. These are the valid combinations. For all the
Yes.
valid combinations, these two values are equal.
Yes.
For all the valid combinations, these two values are equal, and that must be if your two tables contains
Mm.
the common attributes,
From.
means the related attribute. It's not common.
Mm.
Common is not the suitable word here. It's a related attribute. Okay,
Mm.
means the attribute depending on which you can relate two tables.
Mm.
Okay, so these attributes DNO from JEMP
Okay.
and D number from JDEPT
JD.
are the two attributes which can be used as a related used to relate the two tables. Okay,
Mm.
so if you have these two attributes in the
Mm.
combination, then the value of the two tables equal
Equal.
must be equal in this type of query. Okay,
Mm.
so what you have to do, you have to write condition that this is DNO, na?
DNO.
DNO from which table? DNO from
JEMP
which part?
JEMP table.
JEMP dot EMP dot
Dot D number
DNO is equal
equal
to,
to
this is
JD
from JDEPT,
JDPT dot
JDEPT dot
dot
D number.
D number.
So this will become your combination. And this combination is for what? This combination is to distinguish the
True tuples and the
valid
spurious.
combinations among
Mm.
all other combinations. Okay.
Mm.
So this will discard all other combinations, all others,
Mm.
those spurious tuples. Okay.
Mm.
So to get rid of spurious tuple, we must give this condition.
Mm.
Let's apply it. So here we will apply
Where?
where JEMP.DNO is equal to JDEPT dot D number. It is a
Mm.
case insensitive language, so
Mm.
you do not have to worry about the capital letter and
Capital
small
and
letter.
the small letter.
Oh, now run it. See, there are 48 combinations now.
Yes.
Aja, looking at the table, can you? Okay, no, it will not be possible. How many combinations can be there?
Oh,
Tell me, looking at this table.
okay. There should be Sachin one, and again
How many combinations will be there? Right combination is valid combination. Or
valid
you can
combination.
say, we can also
Four we can see.
say JEMP. Okay, JEMP.
Mm.
How many valid combinations will be there?
Valid will be over here apart from there where DA number will be one, two.
No, the valid combination will only be 12 because for every what we have
Department. Okay.
for every employee, okay,
There is
one
one
department will be combined, na?
assigned. Hmm.
So there will be only 12 rows.
12 rows.
So let's run it now. See how many rows are there.
12 rows.
Only
Okay.
12 rows because for each employee there will be only single department number, na?
Yes.
And look at this two field. Look at this two field.
It is having same number, same value.
Same value.
Hmm.
And since these two fields are getting same value, you will get the valid combination. That means you can say that okay, Rohit Sharma works in production department. Rahul Dabir works in security department. Okay,
Hmm.
are you getting the thing?
Yes.
Okay. Now, what was our query? Let's look into it. See, try to
Select
understand one single query
names.
and you will get everything
Hmm.
very easy for understanding.
Select MP names who work in production
Yeah,
department.
we
Now we have to do.
know that this is a valid combination, but we
Hmm.
have to fetch only those employee names who
Hmm.
works in production department. What
So
we
still
have,
query should be
yeah,
continue.
what we did so far, we
Hmm.
find all the employee names who works in any
Different
department,
any
different
department
department. But we need only the employee names who works
from
in
the
production
production.
department. Means
Hmm.
these three names we
Get
should
it.
get. Okay, Rohit, Virat, and Sachin.
Hmm.
So another combination, another condition will be applied here. What will
Hmm.
be that condition? Can you tell me?
Yes. Where D
Where
name
is
equal
where
to
you can put only one where in a select clause.
select
So
clause.
to get another condition, you need those all and or not. Okay.
Okay.
So you will give
And D name equal to
exactly
production.
dname equal to production. Run it. See, these are the three records you are getting.
Hmm.
Okay.
Okay.
Okay. Now till still we have not completed because we were asked to find the employee names only. No?
Hmm. We
We
don't
are
want
asked
all
to
the
find the employee names only,
hmm,
not the all records. But
SSN number.
what we
Hmm.
have found, we have found.
We found all the
So
all
what we
the
will do, we will
select
write f
should
name,
be
comma,
changed from
l name.
L name.
Okay.
Hmm.
Now run it. See, this is the f name and this is the l name.
Hmm.
Okay.
Hmm.
So this is your complete
Query.
answer to this query.
Hmm.
If you understand the logic behind it or these things,
Hmm.
SQL will become easy to you. Otherwise, uh, it will going to be a big deal. Step by step, it's very easy.
Yes.
Um, but you have to think
Uh, prac-
and you
uh,
have to do practice, a good
yes.
practice. Okay. If you can write a good query, then you obviously will get value for it.
Okay.
Okay, so this is the kind of query we
Mm,
are very much interested in. Okay, although we
mm,
will make some improvement over this, because Cartesian product, you know that for this tiny table, only 12 employees and 4
uh,
departments are there. You
department.
already get 48 records. Okay, so
Mm,
think about the
big
employee database
database.
of TCS, or even in your
Infosys,
company. Okay,
Pro,
then
anything.
what will happen if you make a Cartesian product to find the name of the particular
Yeah.
employees from a particular department? So it will be a
Yes.
mess. Okay, so
Yes.
there will be improvement over Cartesian product. We usually in real life do not do for application this
Okay.
Cartesian product. For that purpose, we have something called join. We will do that
Mm-hmm.
join later. Okay.
Okay.
So this is the Cartesian product. Now we will describe the what relational algebra.
Mm.
Relational algebra part. How you can describe this query in relational algebra? Let's see. So very simply, you have to perform the Cartesian product between these two. Na?
Yes.
You have to perform the Cartesian product between these two.
JMP and JDPET.
Okay.
So R
So
equal.
in relational algebra, what you will do, see, in relational algebra, you have the facility to perform the query.
Mm,
You have the facility to break down the query into multiple queries. Okay, but in
mm,
case of SQL, you do not have that facility. You have to write one single
right join,
line,
single query.
single query. But in relational algebra, you have the facility to break it down
Break
into
that
different. So we are
steps.
first breaking it. So
Mm.
R1, first we make the
Get the
Cartesian product. So
P1 into
JEMP,
uh,
Cartesian product,
product
JDEPT,
JDPT.
right? So this
Mm,
is the Cartesian first one.
mm.
After that, what we have to do? We have to
To-
apply the condition.
Yes.
So R2, apply the condition means you have to write a select. So
Mm.
inside the select, what you have to do? You have to write J
J.
JEMP DNO. You can also write that thing, or you can simply write DNO equal to D number. Okay,
Mm.
but for general purpose, I am writing like that. Say JEMP dot DNO.
D, equal to
Where do you need this JDMP dot DNO something syntax like this? When you have the same name column, okay, same
relative
name for the
attribute.
column. Suppose here you have the DNO and here you also have the DNO. Then what you have to write? DNO equal to DNO. That means nothing.
Yes.
That time you have to specify the
Table
table
name.
name.
Mm.
Okay, so that it can identify DNO from
Mm.
JEMP table and
Mm.
DNO from JDEPT table. But if the attribute names are different in different tables, then you do
Mm.
not have to mention the table name.
Mm.
So JEMP DNO and
Equal to
JDEPT
JDPT dot D number.
dot D number, and inside that you have to write what R1. So you are applying this condition on this R1 table. Na?
Mm.
This R1 table contains the Cartesian product, result of Cartesian product. So here you are getting all the, sorry, with that, what you have, you have another condition, dname equal to
D
production.
name. Yes.
So your dname equal to say production.
Mm.
Okay, dname equal to
Mm.
production. So here you will have the all valid tuples. Now from R2, what you are fetching? You are fetching f name and l name.
L name.
So what you have to write? The final result in R, we are fetching
Projection.
f name,
F name, comma L name
l name from
from
R2.
R2.
So this is your relational algebra. Okay.
mm,
Now, this query, we break the query into three different, means three different parts. You can
mm.
combinedly, you can do the thing. How can you do the thing? In one
Okay.
single line. See
R,
here.
uh,
See, you have to start like this.
projection,
Pi. Hmm. So pi,
projection, F
f
name,
name,
comma, L
comma, l
name,
name, from,
from
select.
select,
You have to write
J,
the condition here. Okay.
uh,
And here you have to write the j
J,
emp cross jdpt.
JDPT.
Simple. And this is your r.
Uh,
This is your r. So this is a single line. If you want to go
relational
for a
algebra.
single line relational algebra query, then you have to write
Mm.
like this. Otherwise, you can break it
Write
down.
the
There is no
into
harm breaking it down. Even I think it is better to break down it into different step in case of your exam
initial
or
stages.
initial
Mm.
stages, obviously. Okay. So this
Mm.
is the way how you have to perform the Cartesian product full.
Okay.
Okay.
Mm.
Now quickly we do some more queries so that you
Mm.
can
Mm.
get acquainted with it. Okay, so this will be our query. Keep it there. After that, say, look here. I'm giving you a query. Just try
Mm.
to tell me.
Okay.
Say, if I ask you to find the employee who work under the manager, okay, whose SSN is 1008, who works
One
under
zero
the manager, means a
manager.
manager managing a department.
Mm.
Okay, see here, where is your manager? 108 is this manager, na?
Accounts.
So what you have to do?
Okay. Manager is 108. He's for accounts department.
He is for accounts department. Now you have to
Mm.
find the employee names for accounts department. But
Okay.
don't think in that way. I do
Mm.
not ask you to find the employee name from accounts department. I asked you to find the employee names who works under
Works
the
under
manager
that manager.
1008. Okay.
Okay.
So what you have to do?
Same again. Taking a Cartesian product from JEMP
Yeah, again you
and
have
J
to Cartesian product between these two.
JDPT. Mm.
Okay. So let's try to write the Cartesian product,
Mm.
means the query. Okay.
Mm.
Looking here. Okay. Just try to write the query.
Select F name, comma L name,
Select f name comma l
L
name
from
from JEMP
JEMP,
comma
comma
JDPT,
JDPT,
and we
where
know that the related field between these two
uh,
is DNO and D number.
yes,
So you write DNO is equal to D number. See here I am not writing the JEMP.DNO and JDPT.D
but
number because
where clause is missed, no? Is it fine?
which, where,
Where
no,
that
how
command?
can it be fine? Where must be there,
Okay,
otherwise it cannot understand.
okay. Where
WHERE, where
and
this and
DMGRSSN equal to 1008.
exactly 1008. Okay,
Hmm.
what is this? Okay, fine, 1008. So let's run it. See, Ravindra Jadeja and MS Dhoni.
Hmm.
Let's find whether our
They are
result
the
is okay. So
okay.
1008 is accounts department, and in accounts department, these two employees, MS Dhoni and
Ms. Dhoni and
Ravindra.
Ravindra. Hmm.
So our query is right. Okay.
Okay.
Are you getting?
Hmm. Yes.
Okay. Next one. I am not writing the query statement here, huh? Just like this.
Okay.
By listening the video again, you can write the query statement. Means this is the query statement. Okay.
Simultaneous. Okay. Hmm.
Okay.
Hmm.
Against each query statement, you have to write this thing in your note or
Hmm.
copy.
Okay.
Okay. So where we okay. Now tell me.
Hmm.
I want to know the departments which are located in uh, Delhi.
Department located
Department
in.
name which are
Ah.
located in Delhi.
Okay.
First, looking into the tables, you try to give me the answer.
Okay. I have to merge this means Cartesian product of JEMP table and J department location.
Why JEMP table? I am asking you to find the name of the department which are located in Delhi.
Okay, then J department and J department location we can
Yeah,
do.
exactly. Because this table is dedicated to store the
The
locations of the
location.
department. These are not. These are the employees' location where they live.
Mm.
Okay. So you have to perform Cartesian product
JDP.
between these two. Okay.
Hmm. Hmm.
So after performing Cartesian product, what you have to find? You have to
The
find the D
D
location
location
is Delhi.
is city equal. D location equal to Delhi.
Okay. Then what you will write? Tell
Select
me. Select. I am asking you. I have asked you to find the name of the department which are located in Delhi.
name of the department is D name.
D name.
D name from
D name from
JDPT comma
JDPT, comma
JDPT underscore location.
location
Where
where
uh, here I we don't think so any multiple means what is that surplus tuples what is that
spurious.
spurious tuples may not occur.
Yeah, spurious tuple will occur everywhere.
Okay, so I need
See,
to give this one.
just one thing. See, what is Cartesian product? Means the every combination. So it will be combined with all three.
Okay, then it will definitely come.
So when it
So
is
I should
combined
give
with
this one.
this tuple, when
Mm.
this combination will be
True.
true, but remaining the three
That previous
combination will
zero
be
is
false.
false. So I have to write where D number is equal to
Tell me
where D number.
D number
Here I have to mention the table name because
exactly,
the attribute is same.
because otherwise you have to write D number equal to D number. That means nothing, na?
Nothing. Yes.
So it is your
JDEPT
JDEPT dot D
dot D
number
number
equal to
equal to JDPT location
location dot
dot
D
D
number.
number
So that is the query, that is the condition which will get rid of the spurious tuple, right?
Fourier stubs.
Now
Yes.
your
Where
specific
and
and
condition should come
yeah,
and D location is equal to
D lock is equal
D
to
lock is equal to
then
Delhi in single quotes.
a single code. You got it,
Mm.
and you have already learned. It's just a matter of practice. You just do practice. I will send the query, and you will
Mm.
learn quickly.
Okay.
You have something DLOC, DLO, DLO.
Mm.
DLO is nowhere,
D
na?
lock.
It will be
LOC.
your DLOC.
See.
So
Mm.
you also have to understand the
Syntax
this
sometimes
no
the
this
attribute
thing.
name.
No,
Mm.
what is this? This is
Error
error message.
error
Okay.
message or exception anything
Hmm.
invalid identifier. Okay.
See, security department is located in Delhi. If
Hmm.
there were multiple departments in Delhi, say Delhi, department 5 is located, so department 5 is your security. If there are multiple departments which are located in Delhi, then our result will give multiple
Multiple
department names.
department names.
Is it okay?
Yeah, fine.
Okay, tell me one more thing. We will do this kind of queries, two, three more. Okay,
Okay, fine.
different types of I am
Mm.
giving you. See, if I ask you, tell me
Mm.
the name of the employee,
Mm.
okay, uh, who works in
Mm.
project number triple four.
Okay. So we have to select it from JEMP and uh, J works in
J works in, right? These are the two tables that you need to combine. Because
relate.
what I have asked, you have to find the name of the employee who
Mm.
works in,
Mm.
means which table contains the data about employee and
Employee and
the projects
works.
where he is working.
Okay. Mm.
So these are the two tables now.
Yes.
So you have to combine this table with this table. Okay. So among these two tables, if I combine, which field is the related field?
Triple four. The related field is just one second. So super SSN here and
No,
here
no, no. No, 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 no,
ESSN.
no, not super assistant. Super assistant is something different. You forget this thing. This has a specific purpose. I will tell you. This field, na, SSN. SSN is the ID of the employee,
And
and
ESSN
ESSN
here.
is the
Mhm.
is this thing,
Okay,
SSN.
I got it
Okay,
now. I
I
got
got it.
it now.
Super
I
SSN,
got
you
it now.
just
The
forget it.
difference.
There is a
Yes, yes, I got it
different
now.
concept.
Yes, yes.
Okay. So what you have to find, you have to come into, if you want to do it manually, then you have to first come into here. You have to
Mm.
locate the project number triple four. So
Mm.
triple four are two triple fours are there.
Mm.
So with respect to these two triple four, you have 1008 and
That's 8 and
1009.
1009.
So you have to
So
go
that
to JEMP.
JMP and search for 1004 and 1008 and 9. Sorry.
1008 and 1009. So MS Dhoni and Ravindra Jadeja is going to appear. Okay.
Mm.
But this is the manual task. If I
Mm.
want to write a query, then
So
how I have to write it? Tell me.
select F name, comma.
Just a minute. Let me position the screen.
Uh,
Writing queries are very much funny. Means
yeah.
you will get interest if you start
Yes.
writing the query. Na, you will get interest in it,
Definitely.
and it will pay you later.
Okay.
Select F name,
F name and L, comma L name
L name
from
from
JEMP, comma
JEMP, comma
J works in.
J works in. Do not think about the case small letter and capital letter because
Okay.
it is case
It is not a
insensitive.
case sensitive. Okay. Where
Where
SSN equal to.
SSN. See, I am making a paragraph. Now I'm making a new line
Mm.
here. I'm writing query like this. You can write straightforward. Okay.
Yes.
So there is
SSN
no harm
in
writing
writing
a
it in a single
single
line.
line.
Okay. SSN equal to ESSN.
SSN equal to SSN is equal to
ESSN.
ESSN.
Hmm.
Hmm.
And
And
uh, what is that P number? Na P
hmm,
number
piano
e- equal to PNO equal to 4444
triple four.
semicolon.
So this is your query.
Query.
This will give you no data form because we have to check now.
Yeah.
JEMP, inside JEMP we have, okay, so we have to select the works in.
Ah, strict from works J works underscore in.
We have to see whether we have filled up the
Data in
data.
that filled up the data or not. Okay.
Yeah, we have
We have
444, 444,
and
1008, 1009. And look into the JEMP. Now we are troubleshooting.
mm-hmm.
Say 1008 and 1009 are
0089
showing.
is not.
Yeah, We have 1008 and 1009. We
No,
have the
here
data.
it is 108, no? It is not 1008.
See, right? It is not 1008. Then how can it find?
Edit. We can
We have to edit. So we will edit,
alter that.
alter the table. This table we
Yes.
will alter.
Yes.
See 1008, 1009. So
Uh,
will there be any formula to get rid of the second zero? Mathematical formula, can we find any
mm,
mathematical formula to get rid of the second zero?
divided
No.
divided by
Divided
100.
divided by 100 nahi hoga. Anyway, we will make it,
Hmm.
change it.
Hmm.
So how to modify? See, you remember?
Alter. Yes.
No,
Alter.
alter was DDL command. It is to change the structure of the data. You are going
Yes.
to use the DML command. What was that?
Update.
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 Update. Then table name, na?
Yes. Update
J works
works underscore
in.
in.
Then set.
Hmm. Hmm.
Say ESSN is
Sen
equal to
equal to
what? 108,
108.
where ID is equal to, what is the ID of
One one
2?
108 is 2.
2. So just write
And
it.
mm,
One row updated. Let's check it out.
mm, mm,
See 1008 becomes 108, right?
mm.
Now the
Now
same
we have
thing
to
with you.
just 109.
9, this will be 3.
Mm,
We can easily write a PLSQL code so that
mm,
every record can be changed. I hope we also have PLSQL later.
mm-hmm.
Okay, so 108 and 109 becomes there available.
Now we
Okay,
have to change in query.
no,
Okay, only P number, na? We are not look. We
we
have
are
not
not.
given the condition in that
Yeah,
108.
that is
Only the
internal.
matching. This thing we are checking. Okay.
So you run the query. Now we have MS and
Mm,
Ravindra Jal. Okay,
mm,
so in this way you have to run
mm.
the. You have to construct the queries for multiple tables. Okay,
Yes.
with the help of partition tool. Is
Yes.
it okay? Tell me.
Yes. It is fine.
Okay, fine. Then today I have to stop here.
Yes.
Okay,
We can
so
stop.
I will send you similar queries so that you can
Okay.
apply in your
Okay.
machine. Just try those queries to develop, and if you have any confusion, then you can always send me message.
Okay. Fine. We'll do it. Okay. We'll do it.
Okay, then thank you.
Thank you so much.